Welcome to Unit 3, Lesson 2, where we're going to be covering Chapter 7 and 8 and comparing C strings versus C++ strings. While we've been using the string class since day 1, in this lesson we're going to go a little deeper into the difference between C strings and C++ strings. You might recall that a C string is a character array with a special terminating 0 character. And this is how the C language works with the string type data. That's why we call it a C string or C style string. We'll also introduce C string concepts and some library functions to work with C strings. And of course, your learning objectives for this lesson will be to use the string class and its member functions, use C strings, and to be able to convert between the two. As we explained in Unit 2, some of the C++ libraries originated as C libraries. The header file for those C libraries are called something.h, such as math.h for math functions and ctype.h for character-related functions. C++ wraps those C headers in C++ style headers called C something. That's why we have CMath and ctype. Okay? So the C string header file is actually string.h from C and contains functions for C strings. And the string header file for the C++ string class we've been using, and there's no corresponding C library because it was implemented for C++ only. The string header file specifies the string class, its member functions, and related standalone functions. And the string class is actually an instantiated version of a class template. If you follow the link for the string class instantiation, you see this in the string class documentation. But the question is, what does this typedef keyword mean right here? Well, let's take a look. The typedef statement is used to create an alias name for an existing type. So as you can see here, we've got a typedef, the keyword typedef, followed by an existing type name, and then whatever it is that we want to call it. So in this example, you can see that we are creating an alias name integer with a capital I for the int type. Okay, this isn't to be confused with the Java, how there's a integer class with a primitive int type. Okay, we're creating a new type called integer here. After that, you can use the integer name right here to declare a int type variable. So like here, you can see we're saying integer a equals 10. This is the same thing as saying int a equals 10. Right? So string is actually an alias name for a class template basic string with a char type. So here, standard string is a typedef of basic string with the char type. Okay, that makes sense. C++ 2011 introduced another way to create alias names for existing types with keyword using an assignment style statement. So here you could see, instead of typedef, we're saying using our new name is equal to what our old name was. Then we can say using that new name equals int, right? So this is the same thing as this, except for we're using the using keyword instead of the typedef. So this is all in the C++ documentation. Don't worry about it too much. We're covering this because the documentation specifically says that a string is a typedef of this type right here, and so I wanted to explain what all of that means. All right. So to make it more concrete, let's take a look at this example here. This section of code right here, all right, where we're using a string, we're using standard myString, right, hello world, and then we're outputting it, right, is the same to the compiler as this program down here, where we've got the standard basic string type char, right, and we're passing in this string right here. All right, so these two things are programmatically the same to the compiler. So the typedef is just a convenience to you, the programmer, to relabel things how you want. And in this case, the writers of the library were taking advantage of that capability. So now that you understand that, let's return back to our string class and take a look at some of its common functions. So to access individual chars, you can use the array style brackets, the index of operator, or the at member function. Both techniques can be used to retrieve a character or to modify a character in a string. So this segment of code shows that both the array style, the brackets, and the at function can be used on the left-hand side of the assignment statement, right? Or it can be used on the right-hand side to retrieve the value. So left-hand side, you're storing the value. If it's on the right-hand side of the assignment operator, you're retrieving the value. There is, however, a minor difference between the index of operator and the at function that you should be aware of. Well, first, the brackets is an operator, okay? When you use the index string size with the bracket operator, you will get the null character at the end. This is legal, but it should be avoided, okay? So this will give you the null character. On the other hand, the member function at, right, will throw an exception if you try to access the index that has the null character. So this function automatically checks for that and it'll throw an exception. So this is considered much safer to use. However, many people still like to use the brackets because it's familiar notation, okay? So if you're going to use this, just be aware that you can get that off by one error, and if you overwrite the null character, you can cause some really funky problems to happen in your program. So again, try to stick with the at if you're trying to get a character at a position. That way you can get that runtime exception if you accidentally try to access something beyond the length of the array. Now the string class has a length function and a size function. Both return the number of chars in the string, okay? So this segment of code right here is going to print out the same number twice. All right, and if you look at the documentation, you'll see that those two functions both have a size t return type. Okay, and you're probably wondering to yourself, what the heck is size t? Well, let's take a look at that. If you dig into the documentation a little bit more, which I'm sure you will, you'll see this typedef declaration right here, which means that size t is an alias name for an unsigned integer type. And the specific unsigned type used varies in different C++ implementations. But this size t type is commonly used with arrays and strings where the index should not be negative. So whenever you see the size underscore t, you automatically should think to yourself that this is some kind of integer used for indexing arrays. Okay? So in this segment of code here, you can see that it uses size t type for the index variable, right? So standard size ti equals 0, and then we're using it just like we would use a regular integer. Another thing you might see is you might see it used as an unsigned int, okay? Which also only holds positive values, right? So this is just a convention. This way you're guaranteed to know that the variable is only going to hold a positive value. Now, the next three slides are review of what we talked about last unit, and that's that we can use the concatenation or the addition operator and the compound operator, the plus equals, for string concatenation, right? And this is based on the idea of overloading, as in function overloading, okay? And we'll talk about operator overloading later in the course, but be aware that a string literal in double quotes is a C string and not a string object, okay? So that's absolutely critical. So like this right here, Tom and Jerry, it's a C string, not a string variable. When we use the plus operator for string concatenation, one operand must be a string variable and the other operand may be a char, a string literal, or a string variable. So in this example, me and you are string literals, i.e. C strings, okay? What you can't do though is use the plus operator to concatenate two strings in C++. It won't compile, right? And if you think about it, it makes sense. C strings are arrays which are stored as memory addresses, and you can't add two memory addresses together. Here we use a C string to initialize a string object, and it's okay to concatenate a string and a C string. You can't, though, concatenate a string with an int. Unlike Java, C++ doesn't allow such thing. Again, you can only concatenate a string with a char, a C string, or another string. This last line will compile, however, it's not string concatenation. It will use the int t right here to index the C string. Remember, C strings are character arrays, so adding one will just give you the array starting at the second position. So let's take a quick look at this so you can understand what's going on. So here you can see this pretty much the same code that we had before. We have our integer t equals 1. We have our string literals, our C strings, me and you, right? And then we have our string me, right? If we execute this program and run it, gotta rebuild it. Here you can see the output, right? And we're outputting me and you, and then we're combining string with and you, and so we're getting me and you without the space. So really we should put a space here, right? And then we're couting super funky plus 1, right? And it outputted uber funky. So what's going on here? Well, if we change this to t, right? Obviously we're going to get the same thing. So if we run it again, you can see that our output, if I can grab the output here. All right, so we fixed our space on the second one, but you can see again, same thing, uber funky, it indexed it starting at u, right? So if we change t equals to, say, I don't know, 5, what do you think's going to happen? Well, let's close this out and rerun it and take it for a test drive. So now you can see that we added this integer to it, and all it did was just it started the index at the F and only gave us the output of funky instead of super funky plus 5. Okay, so in Java, this would have combined super funky and 5 and given you super funky 5, right? It would have looked like, it would have outputted like that, right? But C++ C strings don't do that, or excuse me, C strings don't do that, and it just indexes the C string, so you only get from that point till the null character, right? So that's just something to be aware of, and it's a little bit, you don't see this too often, but it's common to do this, and so it's going to give you results that you don't expect, right? Now with the compound addition operator, and again this is refresher from Unit 2, string, chars, C strings, as well as ints can be added to an additional string, right? However, keep in mind that an integer is interpreted as the ASCII value of the character. So this is a little bit different from what we saw with the string literals, and when we added the int to it, it indexed it. This is we're taking a string and we are adding an integer to it, and so that's going to add the integer value of whatever the char is, right? Okay. So and in this case, the int is going to be interpreted as the char. Excuse me. So if this was, say, 65, then it would add the letter A to it, right? If it was 97, then it would add capital A to it. All right, so that's how that works, right? I think I showed that. Yep, here in this example, we have here, and we're adding 65, which is going to append the capital A, okay? In this case, it's going to append the whatever the ASCII value of 2 is, not the number 2 in quotes like this. So here you're going to see these types of results. All right, again, this is a refresher from last week. And again, here we are appending the character A plus 2. We're going to get the value of character C. All right, this will not compile, right, because we can't do that. And we also can't do this because we're attempting to assign a char to a string, right? So this works because we're adding it to the end of it. This does not work because we're attempting to assign it. This is a string. This is going to evaluate to a character. All right. So again, this is all refresher. So let's look at two commonly used string member functions. The first one is the substring function, which returns a substring of a string object, just like the Java substring method, right? The first parameter position specifies the beginning index, and the second parameter length specifies how many characters will be included in the substring, right? The default value for the length parameter is a predefined constant, which is here used to indicate that it's the end, right? So if you don't specify the length, it will use this endpos constant, right? And it's going to say, oh, okay, this is -1, so therefore they want it all the way to the end, right? In this example here, you can see we are using the substring method, or member function as it's known in C, to output the text happy birthday, right? So our output is equal to happy birthday, and we're calling substring, and we're giving us starting at the 6th position all the way to the end, right? Because it's using that endpos as a default value. All right, and that's going to result in that output. Okay. Second member function that we need to cover is the find function, and this is similar to the Java's index of method, and it's commonly used to perform case-sensitive search. So you can search for a string, a C string, or a character as parameters, as you can tell by the overloaded functions. So here we're passing in, whoops, let me get my laser. So here you can see we are passing in a string, here we're passing in a character, a C string, and here we're passing in an actual character, okay? And then we're telling it how many, the position where to start at, okay? So when it's specified, it starts at the beginning, or when it's not specified, it starts at the beginning, and when we actually give it a value, it starts at that index. So if it doesn't find anything, it will return -1. All right. Now, all of that was related to the C++ string class. Now, let's take a look at C strings. And as we've mentioned earlier, C strings are simply an array of characters that are terminated with the null character. And the compiler relies on the null character to know where the C string ends. So it's critically important. In fact, many of the security hacks that exist in the wild are due to improper handling of C strings. So all string literals that are the strings in quotes are in fact C strings. So given this segment of code right here, what do you think is going to print? Well, this is the result. So you might be asking yourself, what's going on with all this stuff right here? Well, let's find out. If you trace the execution, you will see that name1 right here is a size 3 array, and name2 and name3 both have 4 spots, right? Okay, so because here, since we gave it a string literal, it automatically gives us 4 positions for the null character. You can see here that this has the null character included. But in this case, we gave it the name array, or name1, but we didn't give it the null character, right? So if you need to use a character array as a C string, you need to declare the size of the array +1, all right? Array is sent to an O-string object. The O-string assumes that it is a C string, and therefore it has a terminating null character. An O-string uses this null character to determine when the output ends. Okay, if this character array doesn't contain a null character, then the strange output may happen, since the O-string continues to output data from memory adjacent to the array until the next null character is found. And that's why those weird characters are printed out after the ADA from the first print statement. Okay, so let's take a look at this actually in running code so you can see it in real time. Okay, so I have the program loaded up in the debugger, and you can see it's the same program as before. And I've got breakpoints set here, here, and here. I guess we don't really need them because we're just going to look at it in memory. And you can see name 1 is a character with 3 positions. Name 2 is a character with 4 positions. And name 3 is a character with 4 positions. And you can see names 2 and names 3 have the null terminating character in that last position. Null, or name 1 doesn't have any such null terminating character. And you can see that here we explicitly gave it the null terminator, and here it implicitly added it because we gave it the string literal. If we look at the name 1 in memory, if we go to this memory location right here, you can see this stored in memory. Okay, you've got 61, 64, 61, C, 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 blah, 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 right? Okay, if we run it, and if we continue the program execution, right, we can see our output prints out ADA and this weird string of characters all the way up until a set number of characters. Now, 61, 64, and 61 are the hex values of those characters. So if we turn to our lovely hex table here, you can see that A, the value in hex, is 61. Okay, right? No, I can't highlight it because it's an image. But you can also see that D, the hex value is, excuse me, not capital D. You can see that lowercase d is a hex value of 64, right? And so it's going to print out all those, but since this digit right here, let me cut back. Since this digit right here is not a null terminating character, it's going to continue reading that all the way across, okay? And that's where you start seeing these weird IIIs, okay? And this is just how it's displayed. This memory viewer tries to convert it to an ASCII value, but that's why we get these weird characters right here. These represents the CCC, and then you've got this weird plus minus character, which is this N with a tilde, and then you've got an X and an X. And so it keeps going until it actually gets a 0, 0 right here. Okay? That is the null terminating character, and that's when it knows to stop. So if we look at name 2 in memory, okay, which is 0, 0, D, E, F, E, B, C, right? You can see that we have 6, 1, 6, 4, 6, 1 again right here, but then we immediately have this 0, 0 null terminating character. All right, well, that's cool, right? So now, where's the next one? Okay, well, let's look at name 3. We got the same thing except for it's D, E, F, E, B, 0, right? Or, yeah, 0. So if we go to that memory location, you can see again 6461, which is ADA, followed by 00, which is the null terminating character. So that in fact shows you right there that it's going to stop printing there, because that's what the O stream is programmed to do. It looks for that null terminating character and stops at that point. Okay? So that's C strings within memory, just to give you some more background on it. Another interesting thing that I want to point out here, since I have the opportunity, is when we talk about things being added to the stack, you have to remember and realize that the stack actually grows down in space. So the space that's allocated for your program to run, as we add things to the stack, it actually adds them in lower address spaces. And you can actually see that happening right here. So here is the 3 things that get printed out. Okay, and so as we go from left to right, we are increasing our memory addresses. Okay, so this is 1 byte, this is 2 byte, 3 byte, this is the next word, right? So each one of these is a memory address. So if we can see here, this is name 3, okay, and then this is name 4, and then this is name, I'm sorry, this is name 3. This is name 2, right? And then this is name 1, okay? And you can see the null terminating character here and here, but this is the gobbledygook that gets printed out for name 1. So you can see that they are added in reverse order because they're added from the top of the stack down. So name 1 has a higher address position, and then name 2, and then name 3. So I just thought it was interesting that you could actually see that in memory, and I wanted to point it out to you. Now that we've gotten through looking at memory, let's get back to our C strings and discussion of the various functions. The C string header file specifies several functions to handle C strings. The function string copy is used to copy contents of a source C string to a destination C string. The string ncopy copies the first number of characters of the source to the destination. So you can see here it's the same, but we are specifying the number of characters to copy over. And the string compare function is used to compare two strings. And the string, we also have an N version of that, which specifies the number of characters to compare, right? With the null character not being counted towards the length. Remember when I said that C strings were a cause of many security holes? Well, if you try to use string copy or string ncopy in Visual Studio, it will not compile. And that's because it is non-standard C++ behavior. However, you may disable this error message and enable compilation by adding the following to the beginning of your program before of your any include statements. So here you can see we're including a defined variable, and if it's defined, we're going to turn off security warnings, okay? And if you use the standard AFX header, because you chose that option within your Visual Studio options, then you only want to put this in your standard AFX header file, okay, after the pragma once line. We're not going to get into that because, you know, told you not to do that just because it makes it more complicated for our builds that we're doing. But I just wanted to put it out there just so you were aware of it. So I've got this example teed up for us so we can test it out. So here you can see our main program where we've got two named character arrays, 1 and 2, and we stored Ada and Bob, again using the two different types of initialization just so you can see it. And then we're going to print out those names, and then we're going to copy the name 2 into name 1 and then print out name 1 just so you can see the results, right? So if we try running it, okay, boom. It says there are build errors. Would you like to continue and run the last successful build? No. And if you look at it, it says down here in our warnings, it says string copy. This function or variable may be unsafe. Consider using string copy _s instead. To disable depreciation, use CRT secure no warnings. See online for help. So we have that already. If we just uncomment it out and rerun it, you will see that it runs flawlessly and allows us to use these string copy methods, okay? But again, there's a warning there for a reason. We're showing this so you're aware of it, because you might have to work on legacy code. There's a lot of code out there that's still really, really old, and you need to be aware of the dangers of using some of these functions. And we're not going to get into necessarily why it's dangerous, other than the fact that because you can copy an undeterminate number of characters, you can overwrite memory locations, and then later you can go back and execute things based on those memory locations, depending on crafting certain things to put into those memory locations. So again, this isn't a course on security programming, but we want you to be aware of it. So that's why Visual Studio doesn't allow you to use those functions unless you explicitly tell it, mother may I, and put these comments or these commands in the preprocessor. So there you have it. Now, to input a C string without any white space characters, we can use the stream extraction operator. Remember, there must be a spot for the null character, so this character array size of 50 can hold up to a C string of 49 characters. When you input a C string, a null character will automatically be appended at the end of the C string. Okay, so if you do something like this, like, hey, we're going to create a variable called name that's going to store 50 things minus 1 for the null character, so 49, then we can read in up to 49 characters to store in that array. Okay. Now, if you need to input a C string with white space characters, then you will need to use the getMember function of the iStream class, and it can be used to read one single character. And you can read more about it on c++.com. You can do the references, okay? But be aware that there are two versions of get. So this is obviously an overloaded function. One's going to return an integer value, and one is going to return the iStream reference, and you can put the character that you get into a in-out parameter or an out parameter. Okay. You can also use the get function to read a C string. Pay attention that the second parameter needs to be one more than the number of characters that you can read, as you need to leave a space for the terminator. So this is an array of characters that you're passing in as a reference, and you're giving it the size that this is. So if this is 50, you can store up to 49 characters in your schar array. Okay. Now the second version of the string here, you will store up to the size or until you encounter a delimiting character, right? So in this case, it's going to read up to a new line. In this case, it's going to read up to 49 characters or the single quote option. Now, what you have to remember with these methods is that these will not extract the new line character or the quote from the stream that you're reading from, and you're going to have to use another function to get rid of it if you have to call it again. So you're going to read something, and then you're going to have to call something to get rid of the new line or the quote, and then you can read again, and so on and so forth. Okay, but the delimiting character, the default n or whatever you specify, is not extracted. And again, these functions will automatically append the null character. So you can read up to 49, and then it will slap a null character on the end of it for you. We also have a third option for getting text, and that is the getline function. The getline member function of iStream would be a better choice, as it extracts and discards the delimiting character. Okay, so here's an example of using the getline function. We've got our name. We can store up to 50 or 49 characters, and then remember, getline is a member function of the iStream class. So we call it like this, right? And we say, hey, I want you to store whatever you're going to read in. It's 50 characters, right? Minus 1, and then we're going to store it in name. Okay. So this is a much more convenient way to do that. So things can get pretty confusing, but you have to remember that there's two different getline functions, and so we need to be clear to try to clear up some of this confusion, right? There's the function that we just talked about, the member function of the iStream class that works with cstring, right? We are calling it using the input stream object, the iStream object, okay? But additionally, there's also the getline non-member function defined in the string class, in the string header file, and it works with string parameters, not C strings. Okay, so and it's confusing because they're both getline, but one is a standalone function, whereas this one is a member function. See how we have to call it with the iStream object? In this case, it's cn, right? But this one, it just is a non-member function in the standard namespace. Okay, but we have to pass in the string object that we want to extract from. Okay. So again, this can be very, very confusing, and you're probably going to want to come back to this when you're trying to read in information from the command line using getline. Well, which version am I using? Am I working with C strings? Am I working with string objects? I don't know. It's up to you. But again, chapter 3 talks about the getline function here. You're probably going to be using the string version of these things much more often than the C string. So just if in doubt, stick to strings. So since we talked about C strings and string objects, we want to talk about how to convert back and forth between the two, right? So if you need to convert a C string to a string object, then all you got to do is just directly assign a C string to a string object, all right? The string class has the overloaded operator function, which will automatically convert it for you. Now, if you want to convert from a string to a C string, the C string member function of the class allows you to convert the calling string object to a string and return it. Okay, and you may use this directly, as you can see right here. So we are printing out this name string converted to a C string, or you can use string copy to copy it into another C string if you need to modify it later. Okay, but remember, you cannot assign one string or one C string to another C string. You got to use some form of the string copy function, whether it's the secure version, whether it's string encopy. That's up to you, but you can't just say, you know, C string 1 is equal to C string 2, right? You can't directly assign it like you would other variables. One final note about strings is that there's an error in the textbook that states that talks about when using C string parameters with the file open function. And it says that the file name parameter must be a C string, and further stating that if you store a file name in a string object, you must convert it to a C string before supplying it to the file open function, like this. Okay, and this indeed was the case before C++11. However, since then, if you look at the corresponding function prototype for the open function, you'll see that a string version of the file open has been added to the ifstream class. Therefore, you can now directly call open using a string object for the file name, right? So here you can see, hey, we are passing in a string file name, or we can pass in a C string, okay? So wanted to point this out because it's important to consider it, but you might also see this open function in legacy code, so it's important to realize that you can use both, assuming you are using a C11 compiler, okay, or greater. So that brings us to the end of this section of Unit 3. We looked at the string class and the C strings in this lesson. And remember that a C string is a character array terminated with a null character. And since 2011, any string type data can be handled using the string class. C strings are mostly used in legacy code. However, in the C language, C string is the only type for string processing. So make sure you understand these basic concepts and know how to use C string functions, because there's a good chance that you will still see them. We looked at lots of function prototypes taken out of the C++ documentation, and you should get used to learning how to do things by reading the documentation. It's an important skill for you as a developer, as no course is going to cover everything in every language that you want to learn, and you need to be able to go out and read the documentation and understand what's going on, okay? And this is also important because languages change with time, and you need to be able to read up on the changes and integrate them into your work as needed. Okay, so that's it for lesson 2 of this unit.